Now let's look at doubling and tripling investments. If Wendy has $100 to invest at 10% per annum, compounded monthly, how long will it be before she has doubled her money? Okay, so this is getting compounded monthly, which means I'm using the formula A equals P times 1 plus R over N to the NT. So it's wanting for us to solve the how long. So the how long is going to be this T value. So that means I need to have numbers that I can put in for all of the other variables. So A, our end amount. So if she's doubling her money and she started at $100, that would be 2 times 100 is going to be her doubled amount. Principal is 100. Interest rate is 10%, which is 0.1. N is the number of times it's compounded a year, so it's compounded monthly, so that means my N is 12. And I don't know what my T is. So this gives us 200, because doubling 100 is 200. And again, I'm not going to round what's inside of these parentheses until the very end. So again, this is an exponential equation. We have a variable in the exponent. So to solve exponential equations, you isolate the exponential piece and then take the logarithm of both sides. So I first need to divide both sides by 100. And that leaves me with 2 equals 1 plus 0.1 divided by 12 to the 12t. Now that I have this exponential piece isolated, I can take the logarithm of both sides. I'm going to take the natural log. So the natural log of 2 equals the natural log of 1 plus 0.1 divided by 12, all to the 12t. Now I can use that power rule to move that 12t down. All right, now I'm trying to solve for t. Notice that t is getting multiplied by 12 and by this number, which is a number. It's just a really ugly number. So to undo multiplication, you would divide. So to get this t by itself, we'll divide both sides by 12 times the natural log of 1 plus 0.1 divided by 12. By doing that, that cancels out those pieces so that I'm just left with t on the left-hand side. Okay, so that means that t equals the natural log of 2 divided by 12 times the natural log of 1 plus 0.1 divided by 12. And when you substitute that into your calculator, you'll end up getting about 6.96 years. Now make sure again that you're actually checking these values and plugging them into your calculator so that you know exactly how to input these. The biggest mistake that students make is when they put this denominator in, they don't put parentheses around that entire part. So you've got to make sure that you're putting parentheses around the entire denominator and around the entire numerator. All right, another doubling and tripling problem. At what rate will it take for an investment to triple in value if it's compounded continuously over 9 years? So right off the bat, I know I'm using this formula because it's compounded continuously. All right, I'm solving for the rate, so I'm solving for this value. So that means I need to have values that I can input for A, P, and T. All right, so I know I'm going to triple my principal. They didn't tell me what my principal was, but I know I want to triple it. So to triple it, it's going to be 3 times whatever that principal is. So for example, that principal is 100. Tripling that would be 3 times 100, which is 300. So I'm going to set it up like this. So our principal we'll call P, and then our end amount, we want it to be triple that, so 3P. I don't know the rate, but I do know the time is 9. So again, this is an exponential problem, so we need to get the exponential piece by itself, so divide both sides by P. And when I do that, I'm left with 3 on the left-hand side and e to the r times 9 on the right. Now that I have that exponential piece by itself, I can take the natural log of both sides. I can use the power rule to write that 9r in front. So this would be 9r times the natural log of e, and again remember that the natural log of e is just 1. So now to get the 9 or the r by itself, divide both sides by 9, and I get that r is about 12.2%.